0, let's assume that this rises from 0 and it goes up and rises from 0 as the voltage rises up with respect to time. As it rises up with respect to time, the voltage source gets polarized, probably positive and negative. Let's assume that this is the original polarity, positive and negative. So it means that current flows from positive direction like this. It flows outward and flows this way in this direction. So it flows from positive to negative. So it flows this way, and it flows back, positive to negative. So what that means is that as current is flowing through the bulb lights up just a little bit. It lights up as it's increasing. As we're increasing here, the intensity increases. It's like it becomes brighter, and when it gets to V peak, when it gets here, it becomes very, very bright. The bulb becomes very bright because maximum current flows. Remember that V equals to IR. Now what this means is that the more you increase the voltage, this is constant. The more you increase the voltage, the more the current increases. So as the voltage increases, the current through this bulb also increases, and which automatically means that the bulb gets brighter as the voltage is increasing. The current through the bulb and the bulb intensity of the bulb, or the LED, or specifically in this case to be bulb, incandescent bulb, because of the basic architecture of an LED. An LED will not work with an AC input, so we use an incandescent bulb because it allows current to flow in both directions, but we won't focus on that for now. So let's continue. We say that as the voltage is increasing, the resistance of this bulb is constant, so it means that the current increases. As we increase the voltage from this source, the current flowing through the bulb automatically is also increasing, which automatically translates that the intensity of the light from the bulb is also increasing, so it gets brighter. Now at the peak voltage, it's at maximum brightness. Now after that, it starts begin to drop. As it begins to drop, you see that the intensity begins to reduce. The intensity of the bulb begins to reduce. As this drops, it begins to reduce. Now when it hits 0, it goes off completely. The bulb is off. The bulb is completely turned off here, and after now, it begins to increase in the negative direction. And when it begins to increase in the negative direction, what happens is that the polarity of the voltage of the AC voltage source switches, and this is negative and this becomes positive. And that's the case, then the direction of current will change. So current will flow from positive this way like this, and then so the direction changes. Now when current is flowing in the other direction, current is still flowing. As long as current is flowing through the incandescent bulb, it's always going to light up. So whether it's flowing in one direction or it's flowing in the other direction, it's going to light up. Now this starts to light up once again, but at low intensity because the voltage is relatively low. And as it increases, the intensity also increases. The intensity of the light increases. When it gets to peak, negative peak, -5 volts, it's at peak brightness again, and then it begins to drop once again, and it dims down, it dims, and then when it finally hits 0 once again, it goes off completely. And when it goes off, at this point there is no current flowing because there's no polarity, there's no voltage, it's 0 volts, there is nothing, no current is flowing. When there is no voltage in the circuit, no voltage source in the circuit, current doesn't flow. It's this voltage, the potential difference across a load that produces current. So at this point and at this point, there are no arrows, no current is flowing through the circuit. And if current is not flowing through the circuit, then there is no point for us. You are not going to draw any arrow, and the incandescent bulb won't come on when there is no voltage. No voltage from the voltage source, no current to flow, and this won't come on. Now if we start increasing this once again, it gradually lights up, increasing in intensity of brightness until it gets to the peak. When it achieves peak brightness, and then it starts to drop again, then the brightness reduces till it becomes 0. So what we are seeing here is that as the voltage alternates from 0 to positive V peak, back to 0 and a negative V peak, the brightness of the incandescent bulb goes from being completely off, increasing in intensity to full brightness, and then from full brightness it goes back, so you kind of have it blinking. So it's going full off, full off, full off. So this is how you're alternating current. This is how AC voltage, this is how it works actually. So but you might wonder, you might ask that if that's the case, that why haven't we seen, or why is this not visible to the naked eye when we see bulbs that are connected to AC voltage power supply? The reason why that is the case is because of a term called a phenomenon called frequency, the frequency of the voltage, and we'll discuss that next. So let's talk about frequency. Let's talk about frequency. Talk about frequency. Now, when we're talking about frequency, it's the number of complete cycles in 1 second. Now, what is a complete cycle? If I want to draw a complete cycle of an AC voltage, as usual, on the vertical axis I have my voltage, on horizontal axis I have my time. If I start here, get to V peak 0, back to negative V peak. This is positive V peak. This is negative V peak. I return back here. This is one complete cycle from 0 to V peak, back to 0, 0 to negative V peak, back to 0. This is one complete cycle. So how many complete cycles you have in 1 second gives you the frequency. So for example, in this AC voltage that waveform that we have above, we have 2 complete cycles. This is 1 complete cycle, this is a second complete cycle. So we have 2 complete cycles. Let's assume that the duration, if duration from here to here is 1 second, so we have 2 complete cycles in 1 second. So that automatically means that the frequency here is 2 hertz. It's 2 hertz because we have 2 complete cycles in 1 second. That is if the duration of the measured signal from here is 2 seconds. As the time axis is 2 seconds. So now Coming back here, the formula for frequency, or the relationship between frequency and period, is 1 over t, where t is the period. And we know that the unit for frequency is hertz. Frequency unit is hertz. HERTZ. Now, for PHCN, or formerly PHCN, which is now IBEDC, about the Electric Distribution Company, the power supply, the AC voltage from IBDC is at frequency of 50 hertz. 50 hertz. So the power supply we get at our homes from the public power supply authorities is at 50 hertz. Now, what this means, what's the significance of this 50 hertz? The significance of this 50 hertz is that you connect the public power supply to your light bulb. For example, you have something like this 50. You have 50 complete cycles in 1 second. So it means that your bulb comes on, off, on again and off. This is 1 cycle. So it comes on, off, 1 cycle. It does that 50 times in 1 second. So it comes on, off, on, off. 1 cycle, and does that 50 times. So basically that's 100 times. It comes on 100 times and comes off 100 times in 1 second. So it's so fast that you can't tell the difference. You can't monitor the variation in it coming on and coming off. You can't notice the blinking. It's basically blinking about 100 times in 1 second. So it's that fast. So if you can find a way to slow down, if you can record your light bulbs that are connected to public power supply, if you can record it with your mobile phone, your camera, you can find a way to slow it down. You can slow it down to maybe 50 frames per second. You can probably notice the blinking. So, but with the human eye, in real time, you can't see that blinking. So basically, that's what happens. So that is the alternating current voltage. So that is basically how it works. So from there we will go to DC voltage. So we've explained in detail how AC voltage works. So let's go to DC voltage, which is direct current voltage. Now the waveform from DC voltage is pretty much, it's direct actually. It's as straightforward as can be. V peak, positive V peak. You can have a zero, maybe negative V peak, but the negative V peak doesn't matter. It's just positive. DC voltage is at the V peak and it just goes like that, straight line. So this is DC voltage. So DC voltage attains a particular voltage level, which is the positive V peak, and it maintains that voltage level throughout an observed period of time. So basically nothing happens below your V peak unless you change the voltage levels, and nothing happens in the negative side of your voltage axis. So this is how DC voltage is different from AC voltage. Now the circuit, I can just shorten this a bit because since it's not necessary, you could draw it, or it's not compulsory to put the negative part of DC waveform. Let's look at the circuit. If I'm going to draw a circuit with a DC voltage source. Now, unlike AC, in AC voltage source, if you want to draw the voltage source, the symbol of a voltage source, you use something like this. And you don't actually need to put polarity, you don't need to put positive or negative for AC. Because it actually is varying. I just put positive and negative when I was doing an illustration like this for AC. For AC, I did something like this because I wanted to show that it is actually varying. It's going positive, negative, and then the other side at some point to change negative, positive. So the direction of current was flowing this way first, then later on no current, then later this way, then later, so it's going back and forth. The polarity is basically changing. So this is AC. This is for AC circuit. So in AC circuit, you don't put the polarity actually. I put the polarity just to explain. You don't put the polarity, you just the AC voltage source. This is your load, your resistance rather. And then basically that's it. So, but in DC, let's go to DC circuit now. Now for a DC circuit, the voltage source, a voltage source is drawn. The symbol for a voltage source, a DC voltage source, you use two parallel lines, a longer one and a shorter one. The longer one shows the positive terminal, and the shorter one is the negative terminal. Then you do it this way. Then you draw your load, and then that's all. So current flows in one direction. It goes from positive this way, goes through the load back here, and then it sinks in negative terminal. So from positive terminal, it flows through the load, negative terminal. Now if this is a bulb, if this load happens to be a bulb, it just permanently on. So maximum brightness. Once you connect it to a DC voltage source, it just comes on permanently on. So there's no fluctuation. It's not, it's not slowly increasing to maximum voltage and then dropping back.